Hey everyone, this is Eugene, and today we're here with Trevor and Mike. Trevor is the author of the contract that we're going to review today, and this is another episode of Live Contract Reviews. I think it's episode 30, which is kind of cool. And I'll let Trevor talk a bit more about the project first before we go into the contract. And I might need to, if you cannot share. No, it's all good.
Great. So yeah, like Eugene said, I'm Trevor. We've been working on Cron now for quite a while, and we're excited to be finally releasing. Just a quick overview of what Cron is. It's a on-chain cron task runner. So if you can think of tasks that you need to have executed recurring or specifically in the future at a certain time, that's what Cron is built for. It's run by a set of decentralized agents that can trigger contract calls. They know nothing about the tasks that they're going to run, but they're able to execute them at a specific time. And I'm going to show what that looks like. So if you can think about the kind of loop that's happening in the background here, agents are checking for new tasks. They're finding a task that needs to be executed, and they will sign that transaction, and that will execute on chain. If you're a contract developer or an application, you're creating tasks. And to do that, you kind of specify what function you want to call in a specific contract. You can preload it with some funds and then set the time. Like, this example here is, at the 5th minute in August, but there's a bunch of other examples that you can do. Once that is created in the Cron manager contract that we're going to be reviewing today, it will be scheduled into a future bucket that the agents are triggering. And the cool thing about that is there's actually a couple of products here. So you can actually see, like, here's the list of tasks. This is testnet. You can see that there's a couple tasks here for testing. One of them is the counter example from the near example repo. And it simply is just the incremental counter. So this is getting hit every 5 minutes. And the agent would see this in their scripted runtime, execute the task, and then get a tiny reward for that. What I'm going to show now is what that looks like from an agent perspective. So let me switch over to the CLI. This is what the Cron.cat agents get to run. So there's a CLI called Cron.cat. You can just do like status. This is going to show me, oops.
It's misspelled.
Yeah, I did misspell it. There we go. So, I have an agent that I've registered here, and, I have a different account that I get my rewards paid to. You can see that I have 18 near that I've earned for executing almost 1,600 tasks. If we look at what tasks I'm running, this is in kind of the behind the scenes. We have tasks that get run. So it's looking every block, nothing's there, and then finally it'll see like a task that's executing. There's actually a fun bug right now where, here we go. So this just executed that incremental task. You can see this is the output log from that task that I executed, and then I earned a tiny amount for that. The fun bug is that we have contentious agents right now. If there's two agents executing the same task at the same block number in the same transaction, they're actually, one is going to win and one of them's not going to get to execute that transaction, luckily, but they're gonna lose a little bit of their near because they paid for a fee, and the contract panicked. So that's something that we're working on, but that's what it looks like to run as an agent. It's not something that you necessarily need to, you're not the one like at a specific minute doing something. This is just an automated agent that automatically withdraws when the funds are low, that kind of thing. But that's that side. And then from the app's perspective, we're looking for a bunch of people to actually onboard and create tasks. We've got several apps that are working on that now, which is really exciting. And we're hoping to go to mainnet in a few weeks here. So with that, I will hand it over to you, Eugene.
Yeah, very cool. Thanks for doing this. So yeah, let me share the CLI and you tell me if you can see it fine, because I'm gonna share slightly smaller size today.
Good.
So, than usual. Cool. So this is the repo. I pulled the contracts repo. I found a few contracts there. So top level cargo contains a bunch of members. So 3 examples and 1 manager. And we can take a look at manager first. So manager is a contract. I think what is missing here is the release. I don't know. Here it is. Right. So it uses the version 3.1, and this is, I guess, to parse the scheduling, like the standard cron, and 3.2 for contract standards. So manager contains the following. So it has the storage manager from the standards, and that's probably needed to create tasks and stuff like this. So let's take a look. So a bunch of constants. I guess this is the price of the gas and mainnet and testnet. So base fee, callback, agent fee, stake balance minimum. Cool. So what is the stake balance minimum we need?
Yeah, so that's coming in another update, but the idea for Cron is to keep it very cheap for tasks.
Mm-hmm.
We actually don't have a very high fee per task. What we do is we have you deposit all of the task gas that's needed, the fee that's needed, and we stake that for the time that it's not being used, so that Cron service can actually earn interest, and that's its business model rather than you paying additional stuff.
That's cool. Okay, so max block range, max epoch range. Second range, sort of granularity. Level, yes. Okay, storage keys. So this is a task. Already contract ID. Recurring total deposits. Yes, no arguments. So for this thing, we may want to like the arguments, since this is JSON, to change how this serialized. So you can use something like base 64 VQ8, which was a thing. So it still serializes as VEC of U8, or like stored, at least for Borscht. But when you're now gonna give this task in or out, then it will take base 64 instead of array of bytes. So right now it will serialize something like a 64 or like blanks. So ABC gonna be something like 64, 60. Not sure which one is A, but and with base 64 you will save about like 3 times the storage of this. Also, gas is probably okay because we're limited in the size of the gas to be like 300 teragas, so that should fit into like JSON U64. So that's fine. Agent. Also, debug is kind of expensive, but I'm not sure if it's going to be used within the contract. So basically, if you only need debug for like asserts on a test side, then you can move it to config flag to prevent debug from being serialized, kind of compiled into the contract. But maybe it will just optimize it out if it's not used internally. So you can experiment with this.
Makes sense. Awesome.
Another thing that I started using is I started using this. So I guess eventually you'll get rid of this, but you can do this and then you can specify something, some method name that is like a create method name, something like string serializer. And then this serializer is just a kind of separate serializer. And then you can use a regular number. But when you serialize to JSON or back from JSON, it will be serialized as a string. We probably can add this to near SDK, so that would be available, and it will like simplify how we do certain stuff there.
So the benefit there would be a smaller compile footprint plus specifics.
I'm actually not sure if the compile footprint going to be smaller, but it would be nice if it is, and it's possible because it may reuse this. But the benefit is just like when you trying to increment it, you don't need to like put .0 on it. So because you access like a raw value.
For sure. Nice.
Okay, cool. So the main structure, cron manager, post owner, public key, BPS block, BPS timestamp. What is a BPS there?
Yeah, so actually a huge component of this is time within a blockchain, which makes things difficult.
Mm-hmm.
And so what we're doing is creating sort of like a bucket wrapping around several blocks. And we're looking for blocks per second. So we can estimate, here's which slot of blocks it's going to fit into based off of the timestamp, which is in nanoseconds, and then the blocks per second ratio. So that's kind of how we need both of those blocks per second block and blocks per second timestamp, so that we can do an average given 1,000 blocks. So let's say every day I run a method called tick, and that keeps track of an array of 2 items, like a previous and a next, and it averages the now and the previous, so that like an average over that time essentially.
But why do you need a block number associated with time?
It's lower down in the code. There's it's doing that average. I forget why.
Because for scheduling cron, you can just use a block time.
Yeah, the timestamp primarily.
Yeah, the timestamp, but the block number, unless you need it for scheduling as well. Okay, cool. agents, slots. So this is a tree map, which is kind of sorted in tasks. What's the evacuate here? Or like here, I guess. Is it task ID? Or?
Yeah, we store the full task payload inside of tasks.
Mm-hmm.
And then in slot, that evacuate is just like the hash so that you can get the full payload separately. And all you're storing in the slot is the hash.
Cool. Yeah, so if it's a hash, then you may consider using, depending on which hash you use, but assuming you use like 32 bytes hash, since this is a fixed size, you can use something like, I think I had a crypto hash, which is like was ported from near core primitives. Oops. Crypto hash is like a fixed size 32 bytes structure. Since you know that every hash is 32 bytes, you basically just saving some time on using it.
Nice.
What we are missing is like direct method to convert to crypto hash using like env hash or like env SHA to 56, for example. So that would be nice to just like get directly crypto hash. Okay. Boom. So what is the first value here? Is it time?
For slots, it's going to be block number or slot number, really. It's like a rounded, think of it as a rounded block number. And then that way it's more efficient on storage, I think, because you're not storing every single block number. Potentially you're specifying one block number that can hold multiple tasks.
Right.
And it's also nice with the tree map because then you can actually look for, missed block ranges, etc.
As a reminder, Eugene, it maybe has been a while, but the tree map has like the floor and ceiling value, which we can use nicely. So that's yeah. I think you'll see that later, but that's kind of related to what Trevor just said.
Yeah, when I was thinking about like designing well, kind of tree maps solves the issue, but I was thinking about designing an order book, and one of the problems there is like fast iteration on this. So here it actually perfect to use tree map because you usually only have constant number of items that you need to touch from at one transaction, which doesn't create like a huge load on storage. So you always like kind of bounded by ON. So that works well. But when it's not the case, when you like have to like, let's say grab top 10, then like tree map starting to like be a bit expensive on storage operations. Anyway, so this is not needed because it's already included in 3.1 of near SDK, so it's automatically called. Owner ID is assigner ID. Okay. Measure storage. We're basically doing the insert an agent and measure how much it costs to store this agent. Cool. Remove it. So migrate state. So this one is actually probably worth to change who is the predecessor here on the migration. So because when you call the migration, you usually call it because you modified the contract. So to modify the contract, you actually need to issue this transaction from the account of the contract itself. So conveniently, near CLI also let you initialize the contract in the same transaction. So what you can do during the migration, you can do basically something like near deploy, basically calling deploy again on the cron test, then you specify something like res, whatever the binary cron wasn't. And then you can call migrate state and pass the arguments there. And this way, the owner is actually the current account. Well, the predecessor is the current account ID. But what it will do, it create the first action is deploy, second action within the same transaction gonna be function call to migrate state is empty arguments. And then that pretty much prevents someone else from calling this method and trying to deserialize the invalid old state that you already modified. So you can just check. Basically, you don't need to verify it based on a previous state, but instead you can just verify it based on a comparing to current account ID. So you can do something like this. You can make it private, and that means it only can be called by itself. So you don't need to do this verification.
That's awesome. I actually have a question on this, which relates to, we're shifting to a DAO, like a Sputnik V2 instance that would own this. And the migration would take place by the DAO agreeing on a specific contract hash at a specific address that would be able to deploy bytes, like send the bytes to this contract to replace itself.
Yeah, so the V2 will need an extra method, something like upgrade or like receive bytes that is taking it and like converted it into and execute. But during this upgrade, you can also schedule migrate method call always to be called, and then you can just put it as empty if it's not needed.
Nice.
So also what you can do during the migration is you can grab, like when you actually need to implement the migration, you can grab and say all cron manager, and you only need verse deserialize on it. And then here you can just use this variable. So this way, your cron manager is actually the new contract, but you use the old state like only here, only within this method to migrate.
Awesome. Okay.
Cool. So next is tick. So this heartbeat used to 8 computational block per second. Okay. Previous block, timestamp.
Yeah, so the previous blocks, the block numbers are used for how many blocks we're looking at, you know, previous and now. So that'll give you the total, and then to calculate the average, then you have the other number with the timestamps.
Yeah, that sounds good. Cool. Well, the only maybe missing piece is like is some kind of check here that it's not called within the same block. So like someone can just call it twice in one block and you'll have 0, 0. Or like same block timestamp, same. So you'll lose this information. So maybe you can do the like, if the previous block is not longer than 100
Good
blocks, then
catch.
we're not gonna check it.
Yeah. Nice.
Okay, get tasks, so view call to offset how far in the future in current slot. So based on offset is doing the number of blocks from now. Yeah, basically the assuming the blocks are produced roughly once per second, then you probably don't need to worry about the actual block numbers, but can rely on a timestamp. So like if your granularity is in minutes based on the standard cron schedule, unless you can enable seconds later, then
Yeah, I think the thinking I was having there is as blocks, the farther out you schedule things, the block numbers get different. So I was finding in testing that we would have a task, 12 hours from now that actually was off by about 5 minutes. And so I was trying to get that to be more regular, like something that's more predictable within that minute range.
Yeah, but why not? Why rely on block numbers instead of like block timestamp? So like you can just, if you do the granularity like slot space on the minutes, like just divide the nanoseconds into like whatever 60 billion.
Yeah, that's true.
Then you can go get like actual slots based on minutes, and then you can you don't need to like worry about the block production so long as they kind of fit within the time
There's
slots.
two use cases. One is just time-based, purely time-based, every 5 minutes, for example.
Yeah.
The other one is a direct, like an ICO. They're gonna launch at X block, and I think if we can do it with just the timestamps, then that probably is the way to go. I guess what I was just thinking there is, we can have known blocks to schedule things.
Yeah, makes sense. For custom logic, so like if you just based on time, and then custom logic can be something like a separate contract potentially that is kind of handling the precise stuff. So you say, hey, I want to be called starting there every, for example, minute, and then I have a separate cross contract call that's saying that is the block numbers legit or not. But yeah, like exact block numbers is interesting as well. Okay, yeah, let's go through the block numbers. The current block number, slot ID. If there's slot ID, otherwise just current. And then slot granularity. It's So what this there's no division here, so how that slot is computed?
You're just trying to round to a block number and then at minimum forward schedule one slot from now. So you're basically like, there should be subtraction that
Oh, I see. I
takes
see.
the remainder. Yeah.
Yeah, makes sense here. So you got it. Cool.
The granularity currently is hard coded in one of the constants that we first saw earlier, which is 60.
So basically,
Yes.
if it's not a current, if offset at least one, then it will be the next slot, kind of, right? No. Because current block plus 60, if the offset is one. So. Oh, it's computed here. Okay, it's a bit okay.
It's there's two ways of using this function. One is with an offset and one is just no offset, pass me the next or to the current slot. The offset means, you know, look forward looking and then take the remainder.
Yeah, basically you already missed the current round. That's why we'll return the next round. But if offset is none, you will return the current slot. I think there is an issue because next is always going to return, or like if offset is at least one, then slot reminder, let's say, gonna be one. Slot round is gonna be slot granularity instead of 0. Then next gonna be current block plus slot granularity. And to return next, so we'll return the next slot instead of the current slot. But if the offset is 0, then you return the current slot.
I think that's expected behavior, right?
Yeah, I'm trying to remember the use cases. Expected
Anyway.
behavior, yeah. It's offset by slot, not block.
Offset by slot.
So like if you had offset of 1, it should be plus 60.
Well, then you need to multiply it somewhere here, like instead of, because this one is not multiplied by granularity. Anyway, you can figure out later like how the offset's supposed to work. It's not as critical. Okay, so it got the slot ID. And we get the ballpark. So this, I guess, how you. It's on tree map. So if there's some value, then we get the tasks, and for every task, we push this. That can be just map. Something like, so you don't need a copy of this vector because you consume in tasks, so you can do something import here. And this is gonna give you a vector. You can just map inner values using this. If it's not gonna complain, you can do the, you can even do read.into. Like this from. Do from. So that's the same stuff. This way, kind of you're avoiding copying, but you could do the for as well.
Nice, I like that.
Okay. Cool. So get all tasks at the given slot potentially. And then another Rust trick is you can use 128 slot number, and this way it kind of like pulls it down, so you don't need the 0. Okay, so cannot find tasks for a given slot. Should you in this case just return like empty vector instead of panicking? Yes, it's not as critical for the view call, but easier to process probably. Then by the hash, you go through the list. Yeah, if you wanna like return an empty, you can do an or default, unwrap default. This way it will create an empty vector, and that will just not do anything. So you return tasks and otherwise return all tasks. Cool. Also, another thing you may want to do is to limit the number of tasks you return. So for this, kind of provide a limit here, so you don't just iterate on all of them, but use the pattern that we use very commonly, which basically goes from a given index to some other index. But then you may want to also get tasks by slot. So like, okay, give me like next five tasks, or like next tasks from next 5 slots. Or like just start giving me next tasks until you reach some limit that may go through the iteration on the that map on tree map, and then like collecting using flattening.
Yeah,
Okay.
definitely going to add that pagination.
Debugging. Excellent. Well, I guess that's fine. I can remove this. Okay, get test. Given a hash. Cool. Create tasks is available. Contract ID, function ID, cadence recurring, deposit, gas, and arguments. So first thing is contract ID. Since this is an account ID, we should use in a previous SDK the valid account ID, but in a new SDK it should be it should be just account ID, but we haven't released the new. So if you want to verify that this account ID is at least satisfies the near stuff, it may not exist, but then you can at least be sure that you can schedule this call successfully and not panic on the that cadence. So since this is a stir, it makes sense to avoid copy. Not that it's critical, but you can do this. Instead of using the signer account ID, it probably makes sense to use a predecessor because the predecessor is paying for the task. So when signer can be like the account that paid for the transaction, even so.
Yeah, I guess we missed that one.
So this is how you convert the valid account ID. For now, again, false. Okay,
Actually, we did it on purpose to see if you would catch it. Good job.
I ignore the owner one from the constructor because it's not as important because you call it only once to create the cron. Touch deposit, total deposit. Now that map wrapper else. Yeah, that's a bit weird one because you first cast it one direction, then cast it another direction. Gas unwrap a gas base, then unwrap or empty arguments. Cool. So that may better be unwrap or default because otherwise you kind of initialize or like take in memory for this vector. Even so, it doesn't matter.
Does that work with the base 64 vec stuff that you were showing above with the, I'm less familiar with the defaults for those.
Well, that's a good question, but for a bunch of them, we didn't do default, so we forgot to add default, so it's problematic. But ideally, there should be one here. So if you don't have a default, but you know how to initialize this, but then you can use unwrap or else and do something like this. So this way, it's not going to be called. So you're not going to allocate the memory for this unless it's none. Okay, call balance used. Check that the balance is sufficient. Okay. Deposit plus task gas plus agent fee.
So the deposit is a per task need, which is similar to amount if you're doing near CLI.
Got it. It kind of can overflow here, but probably not as badly because it will panic on overflow check. Also, the gas isn't gas, so you may want to convert the gas to the balance here by multiplying by the gas price.
Yeah, that's a good point. We missed that. We do that elsewhere, but not here.
Good catch.
Yeah.
Min balance needed is recurring. So this check can be done something like this, so you can compare it to sound true. So you don't need to unwrap it basically. Okay. Minimum balance needed. Less equal than total deposit. Okay. So computing the hash. Then we see contract ID, function ID, cadence, and a CASAC. So CASAC is a bit more expensive than SHA, so I think so. But they both produce kind of the same size, 256 bits. So I would suggest to replace this with SHA.
Would crypto hash that you were showing earlier have a function as well, or just a storage
No,
type?
it's just a type, but so there's two options how to produce it. So one of them is like you do like vec, then you do like mute hash, like h res with the hash default, and you do res copy from slice, and then you do vec something like this, and then you return res, and that way you can return the crypto hash. Another option is you can do try into and wrap it. So basically you can, I think it has a function to convert a vector into this array of this size. Back to CASAC for now. The other problem with this is if this task is actually non-unique because someone else is calling the same task, then you may have an issue. where someone like schedules the same stuff. Like,
Yeah, I
want
guess
to
it
call
needs the owner in there as well, not just.
I would just say use a global increment and just like every time someone tries to create a new task, just increment it. Even if you're not saving this task, just rely on that. That way you just have U64 and don't need to deal with hashes.
I guess the problem there is that I'm trying to be predictable on the response of this hash so that you could actually compute the hash of a task and be able to address it rather than having to store the hash.
Right. There might be some issue as well in terms of like if the same account creates the same task again, then with a different amount and you already have a previous one which you may need to delete or overwrite. So the hash conflicts just needs to be dealt carefully there.
Yeah, makes sense.
Gets load from cadence. Next from current timestamp. So this already, does it works with nanoseconds? So like how you use the like.
Yeah, there's lots of places where we convert from nano to milli. I can't remember exactly how this works though, off the top of my head. Yeah,
But what
we
about
spent
the
a lot.
schedule? Like, is this schedule is something that a standard or you implemented it separately?
Yeah, so this is the REST cron library that uses, I think, millis, and under the hood, it actually uses like a UTC and a bunch of other stuff. So this is actually modified from that standard to support just millis and return millis rather than like a UTC.
But here you have that in nanoseconds. So this check is like why I was looking into this is like a bit weird because
if you go down, if you go back to that next after method and scroll down a little bit.
Yeah. Here?
No, like click in the definition.
Next outer. Yeah.
Yeah. Scroll down a little bit.
So
you scroll up. Yeah, so 106 and around there is where, yeah, there we go.
Got it. So it might make sense to just like use the standard schedule. I guess you need seconds and then like convert it as early as possible to like milliseconds or whatever you need as a precision.
Yeah.
Or like seconds and milliseconds. Then you don't need to like deal with that within the library. So, but yeah, fine, cool, got it. Next div, block total. Yes. Block total by nano by its denominator divided by current block. Cool. Right. So this is block per second in nanoseconds, right? And denominator as well.
I can't remember, but we spent a lot of time here getting it right. It's like a lot of like, yeah. Yeah, that's the part you're highlighting right now is where magic is made.
Right. Cool. Okay. Sounds good. Okay, let's go back to next slot. So we insert the task by hash. Here you may want to like panic if the task already exists. So you can do is none. So like task already exists. So what it basically, if it's some, it means there was some previous value during the insert. Okay, slot, next slot to Vic. Push. Push. And save it. Sounds good. Okay, update task. So you give the hash, cadence, deposit, guess. If passed, cannot, otherwise get the hash, task, verify the owner, good, cadence, given, we validate the cadence. Oh, I already messed it up. If recurrent, we mark recurrent. And deposit. Yeah, so the hash is probably like very often. Yeah, it needs an owner at least. Then only the owner can mess it up for themselves. Deposit, gas.
Wait, we don't have that at the top. Only owner can update their task on like
No,
423.
It's he's talking about the hash is generated from function, contract, and cadence, but it also needs, for uniqueness, the owner.
So you can write it this way. So this first option, like you can write it as you put it there. Another option is something like a bit weird, but you can probably write it on the wrap or the previous value. I would prefer this option as a standard one. Well, except without unwrap, because it kind of unwraps it here. Yeah, this is kind of strange way if so. Cool. But if you change cadence, don't you need to like modify the scheduling?
Yeah.
So that probably needs to be done here.
Yeah, that's a good point.
And if you made it recurrent, then maybe your pricing needs to be satisfied by minimum amount. Because like last time you checked it and like gas can be more expensive. So the cadence, probably what you want to do is remove it from cadence here and then maybe add it back here, but verify the pricing of this task. Similarly, how it's done here. So this can be a task method to compute required balance. And then you or even better, just like don't do update task at all. Like just let people delete the old task, which in theory should supposed to remove it from cadence.
Yeah, I like that better. It can get really scary if you update cadence stuff. Much better to remove it.
So get the task again. So this shouldn't be private. Well, not this type of private. So it should be, since this is not a callback, it should be like this. So it should be like internal. And then you can just give a task directly here if you have it. Okay, get the task hash, task deposits, then we return the deposit to total deposit. We remove the task. So this can be combined here. So you can do remove here. And remove actually returns you the value. So you can save on the extra lookup, I guess. Get the next slot, then you go through vec. Find the slot and remove it. Maybe you can use retain, but then
Is that a rest thing?
yeah, so retain is like a method that keeps all values that are not that are satisfied. So basically you would write something like this. And then you do this. So
That's really cool.
I guess I'm not complaints. Yeah, that's how you do this. So in the pop-up. Right. Okay. Proxy call is execute a task based on a current task slot. So this is basically what they called by the agents, right?
Yep.
So
Exactly.
they just call the proxy call. House, no. Agent. So this is also may need to be a predecessor.
That's where it gets weird. If someone's, let's say a DAO, becoming a cron agent predecessor makes sense, but with the scripts, I want the agent to be the signer. Unless you guys think that that's not necessarily needed.
Well, what I can do is like, let's say I have my contract and I have extra gas, I will be like agent, kind of spend someone else's gas on my contract transaction to call this proxy call as like, hey, I have like 10 tera gas extra. Here's a proxy call. Then I would want to earn this instead of the signer. But yeah.
I mean, that's as long as you can predict that there is a task to call, otherwise you're burning your gas. But that sounds really cool.
Yeah, that's someone else's gas.
Yep. Oh, true. Yeah.
But then
awesome.
I don't know how much gas I need to pass. So so if it's like a cheap task, then yeah, if it's expensive, that I cannot do this. Cool. Agents not registered. Cool. And current slot. Then we get slot option. Slot ballpark. Wait, why do we need both of this?
So it attempts to use the current slot, and then if it doesn't have any tasks in the current slot, it should go get any missed tasks in the floor key. So maybe there's a better way to write this, but that's the idea.
Yeah, the problem is like it just overwrites it if it's in ballpark. It doesn't check that it's empty. So it always uses the ballpark. Doesn't check that.
I think further down it says, are we using the floor key?
Yeah, but you already overwrite this here. The way to write it might be like check it here first. It's like if slot of is none, and then do this, and then move it out of here. And then, well, I guess you need another false. This way, you kind of like, if you already have it in the current slot, then you don't go for the floor key. You don't need to do this. All right. Dash. We get the what? Found. Nothing. No. Mistake. So I guess you need it then. Well, that didn't work. So in this case, you need to basically because you need to know this slot ballpark here. Well, it just means I need to move the else here. But then you don't want to do this check at all. So then make it mutable then. And do this stuff again. So basically, if slot opt is none, Then we do slot ballpark. Don't need this, use something like this. So we check that if this is none, then we query the ballpark and then we check if it's available, then we get it. Otherwise, we do not. And now you can basically here use again the same check and use key here. Something like this, except here you also need to clean it up properly. So you can also use else Karen slot, for example. This way you always have it. So basically the problem is like the scenario was a bit weird.
Yeah, that's much better.
And then you don't need this as well. So you can do, if it's empty, then we do this, except we panic with this. We say, hey, no task found. Then it's a bit strange because when you get it, it can be empty as well. It was before, so to avoid further modifying it anyway. Because here what you need to do is you don't want to reinsert it if it's like less than, like if it's empty now. So if slot data is empty, then you remove it. Otherwise you insert it. So, cool. So we get in the task. Now if the balance uses balance more than total deposit, then we say, hey, no balance. Otherwise, we create a promise with the task. Okay, contract ID, clone function ID, arguments, slice and deposit and gas. And then we do promise then our callback with the task hash given hash. And I guess for callback, we'll return this. Okay. What we should do is to charge the task. Charge the task here. So the problem is two agents call the same task twice, and we removed it from the slot, but we didn't charge the task. So I guess we only charge it at the callback time. So instead, we probably should charge it here, save the task that already has like less balance, and maybe like roll it back if it failed, but probably not.
Well, either way, it's going to be spent on the proxy call. And we're forwarding the cron manager contract balance to execute this, right? So since we're adjusting that here in the callback,
Well,
this logic
sure.
used to be above actually, and we've kind of been going back and forth. So the question, maybe you can answer a preference here, is like, if you write a task and that function call fails, you're still going to be losing funds no matter what. So do we just, hit it and charge after the fact if it went through, or do we charge and then if it doesn't go through, you've spent that anyway?
Yeah, I would probably say,
Like the agent should get paid either way.
yeah, the agent should get paid like right here. So agent just scheduled it, they should get paid. Whether the task succeeded or failed is a different story. Like, because that whole thing gonna be rolled back if we cannot schedule the actual call. So
I do think a useful use case for this to remember is that like people may intentionally use failure to indicate don't keep calling me. So if I want to do some sort of like migration or something, and I can say, hey, there's like 170 accounts that need to get migrated. Here's 5 near, keep calling me until I fail the transaction because I finished migrating. Then it will like seize the failure and it doesn't schedule the next recurring event.
oh, I see. So the recurrent only gonna be called if it succeeded.
Yes.
Exactly.
That's the plan.
Yep.
I see.
So we don't want to just be burning funds for no reason.
Well, I think it should be separate mode, like
Occasionally it can fail and that's okay.
Yeah, well, yeah, something like recurrent, and then recurrent until failure. So they may be like 2 different modes of the method, because very frequently you're probably gonna get methods that like, hey, let's attempt to like do something, and it's like, oh, like I'm already the progress is already there on this contract, so I'm just gonna panic to exit earlier instead of making sure I'm successfully doing the execution.
That's good feedback, thanks. Okay.
Also, the problem is redirecting So the way Near works is this results, you cannot be sure that the promise succeeded or failed. So they can take your deposit and redirect the execution to next call. So you may think that the promise has failed, but it may have succeeded first time, or like first call, and then failed at the callback. So the tokens are gone already in the first call. That's why we should always charge the balance, no matter whether it succeeded or failed. So like this task deposit, like it's kind of like no return money should be for the task. And as for continue, yeah, it may be like a separate mode. Okay, anyway, let's look what happens. Call balance used gas on gas price. So this is actually not for the transaction cost, it's for receipt. So it's only your gas. And you cannot measure how much they spent.
Wait,
That's
hold on.
it.
Can you say that again? I think I made.
So used gas is a local value. It's not passed through. So prepaid is only like it's within this callback.
Yeah.
So it's not. It doesn't mean that the task spends some amount of gas. So
that's the issue then. Like if someone says,
but you know how
use-
much gas they spend, because task gas is like how much you should charge for.
well, we're gonna be overcharging then, not. So let's say it's,
Yeah.
that gas value is 30 teragas and they've only used 5 teragas, 25 teragas is gone.
Yeah, that's okay. The task is kind of paying for this. So they should like manage to provide
Okay.
a reasonable gas.
We'll just
that
get
they think.
explicit on our documentation about that then.
Mhm.
Okay.
Plus, like there's extra cost, right, for this your own callback, and like so the agent is kind of paying for that, plus scheduling cost of all of this.
Yep.
And like all the mass here. So agent balance plus extra balances. Yeah, you sign a ID for the agent, so that works easily. If you want to use predecessor here, like as a to identify, then you just need to, in addition to pass the agent account ID to the callback. Okay, next. The current slot might have changed. So while the callback was in flight, so you may want to consider passing the previous slot as well.
So if you executed at say like 59 and then 60 triggered on the callback.
Yeah. Yeah, it's like 2 blocks later because you call
Yeah.
in some remote and like getting back.
Okay.
Okay. So we give the balance to the agent and tasks executed. And put the agent back, total deposit, call fee. What is the call fee here? Okay. So we didn't charge the task the deposit. Yeah, so the call total fee doesn't include the deposit, so the task is kind of like freeloading on the Cron balance right now. Because we charge it when we schedule this here at the amount, but not, we shouldn't give it back to the agent because the Cron contract paid for this, but we should charge the task for this deposit as well. Ideally, yeah, ideally before scheduling it, so like make sure that the task cannot schedule twice, like when agent calls in the same block. Well,
Yeah, good call.
not gonna happen, but yeah, right. Agent cannot do this, but if the cadence is like every minute, and then first agent calls this task on the previous slot, and then second agent calls it on the next slot, like in one block, then the task will be double charged. Because the balance will be subtracted only at the callback, which is 2 blocks later. So the first one will not arrive yet, but and which means the callback gonna fail for the second time. On overflow. Okay, if the task is recurring, not recurring, or the fee is more than what left, or we failed, then we exit the task. Otherwise, we're scheduling the task again. Oh, I guess it's not scheduled twice because of cadence is only like appears once. So if you call it the end of the block, the second one cannot call it because it's not in the in the schedule until it completes the first call.
I guess it would break if that callback didn't trigger somehow. If the first promise fails, it will call the callback, right? Or will it just revert?
Yeah, it will fail. It will call the callback, but it's not gonna do this, right? So,
Okay.
so that will be false in some way. Cool. But yeah, you still shouldn't rely on this. I guess it's only used for rescheduling it again. Also, maybe the amount of gases may not be enough for the callback because tree maps are getting actually pretty expensive with the amount of data they get. So like once the depths start to grow, you kind of increasing it. And if for some reason you trigger a rebalancing of the map, which may be triggered here, like when you actually insert it to the next slot, that may trigger rebalancing. That when your gas can go crazy. So
would I know about that? Like, would the receipts or anything represent a rebalancing like that?
It will be just randomly like exceeding the gas at this, and you will not be able to close the task because it's only 15. So that's why I'm recommending like move entire logic.
Yeah.
Like here you only need to decide whether to continue the call if it succeeded or failed, right? So that the only logic you need is this. So this is kind of like the only reason why you need the well, you thought you're getting the gas correctly, but because you're not getting the gas, then there's no actual reason to do this as a callback unless you want to keep the logic of stopping the task when the actual execution has failed for the first time.
That makes sense.
This way, if you like decide to not do this for now, then you can remove callback entirely and do all the logic here. So that's include rebalancing, rescheduling, charging, and paying off the agent. Then the agent just attaches way more gas because they get in full refund anyway.
Mm-hmm.
So that way you can have predictable amount for this callback, like just rely on the agent giving more gas once it's getting more expensive. Now,
Okay.
to address the stopping logic, you can just give it to other to another contract. Like maybe you can have some kind of another contract that does auto stopping tasks that may be doable by like, yeah, instead of calling the task directly, you call the auto stopper that will track the execution of the task, and if it's failed for the first time, then it will call back and say, hey, go actually exit this task. So that way you would simplify it. Okay, we kind of like way over time, but let's finish the agent.
Yeah, I appreciate your time as well. This has been amazing.
So register agent is takes the agent and a payable account. So getting the deposit. Acquire deposit agent or predecessor. Then if there is an existing agent, then we refund. So yeah, if you're panicking, you don't need to do refund. So you can just like panic here. The refund will be done automatically because the entire thing gonna roll back, including the predecessor will get the deposit. Payable account of predecessor. Shouldn't you not let register agents for someone else account? So in this case, like agent should always be predecessor and not be provided. That way,
The agent account should be the signer or predecessor, and the payable is like you could forward your rewards to another account.
yeah, I agree with this, but then you can, like right now, you can pass the agent account ID to be, let's say I can register agent on someone else and become payable.
Scroll up. Is that true that you can pass that in? Because that doesn't make sense. You're right.
Yeah.
Oh, okay. Yeah, that was not intended.
And we give a refund for the remainder. Okay, good. Okay, update agent, so you can basically, it checks that the pausing. You can check that the payable is So here you use signer, but here you use predecessor correctly. So maybe,
Yeah, I think we'll switch to predecessor.
yeah, here it should be predecessor for sure, because you can trick someone to change their payable account.
Yeah.
And also, since this is kind of method that like dealing with money, maybe it's worth to check that it takes 1 octane year for this call. So you cannot call it through access key.
Okay. Yeah, that sounds good.
But people not likely to use agent accounts for this type of stuff. So that's good. So not going to be an issue. Basically replace the payable. Okay. Unregister agent. Sure. Checks the octane year. Okay. Let's draw task balance. Agent account, predecessor, more balance. Yeah, that needs to multiply by the storage bytes cost here. Let's draw amount and insert agent payable account, basically transfer into payable account. Cool. No agent. Get agent, cache, task, validate, slot ID. Cadence, update settings. So this owner.
Yeah, we're going to be removing the public key thing and make it just ID so DAO can be the owner.
Cool. And this is, I guess, somewhat standard. Just quickly scrolling through this to just make sure. Okay, cool. So that's it for the review. Thanks for sticking out. It was very interesting use case in the contract.
Thanks a lot, Eugene. Appreciate it.
Yeah. Thanks everyone for watching. Bye. Till next time.